Hello everyone, I'm Rahul Baghel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai, and the course co-coordinator of the Industrial Automation and Drive. Today, we have reached the final video of our course on Industrial Automation and Drive. Over the past 12 weeks, we have covered a wide array of topics from the basic of electrical system to advanced SCADA programming. This video series offered a comprehensive exploration of industrial automation, electrical system and control technologies, progressing from foundational electrical principle to advanced automation and SCADA programming. Let's take a moment to review everything we have learned and highlight some of the key takeaways from the comprehensive journey. So, here is an overview of each week's content and its significance. Week 1 is focused on the fundamental concept of electrical system. In this week, total 3 lectures are there. First lecture is overview of electrical system in industrial automation. Second lecture is introduction to basic electrical principle, and the third lecture is electrical components and circuit. First lecture is taken by me and second and third lecture taken by Professor Sanjay Agrawal, who is course coordinator of this course. In the first lecture, we covered the introduction of industrial automation, overview of electrical system in industrial automation, integration of electrical system in industrial automation. In the second lecture, Sir will talk about the basics of electricity, charge, voltage, current, resistance, and also talked about the Ohm's law, which connects the voltage, current and the resistance, and also discuss about the energy and the power in electrical circuits. In the third lecture, Sir will talk about the basic electrical components, resistor, inductor, capacitor, switch gears and relays, basic circuit configurations, series and parallel configurations, and the basic circuit analysis technique like Kirchhoff currents law and Kirchhoff voltage law. So, we can say that in the first week we started our journey with the basic and overview of electrical system in industrial automation. This week laid the groundwork for understanding the electrical system that form the basic of industrial automation. This foundation was crucial, setting us up to understand more complex topics later in the course. It covers essential electrical principles, components and circuits which are crucial for anyone looking to enter the field of automation. In the next week or in the second week, we focused on the network theorem and electrical wiring. In this week also we have 3 lectures. Lecture 3 is based on the electrical concept on network theorems, and lecture 4 is based on the network theorems part 2, and lecture 6 is based on the electrical wiring. In this week, Sir will cover the mesh analysis, node analysis, delta and star conversion, superposition theorem, Thevenin theorem and Norton theorems. So, we can say in week 2 we dove deeper into the world of electrical engineering with network theorems and electrical wiring techniques. These skills are essential for analyzing and troubleshooting circuits, a daily task for any automation professionals. The lectures on network theorems provide a deeper understanding of how electrical circuits behave under different conditions, essential for complex circuit analysis and design. It introduces practical skills for safe and efficient installation and maintenance of electrical system, which are critical in industrial environment. In the third week, based on the introduction of industrial automation, in this week total 4 lectures are there. Lecture number 7 is based on needs and benefits of industrial automation. Lecture number 8 is automation hierarchy and basic components of an automation system. Lecture number 9 is PLC Fundamental Part 1 and lecture number 10 is PLC Fundamental Part 2. Lecture number 7 is taken by me and lecture number 8, 9 and 10 taken by Mrs. Swati Verma. In lecture 7, we covered the need and benefits of industrial automation, and we will explore how automation transform industries, enhance productivity and drive economic growth. In lecture 8, focusing on the two fundamental concepts in industrial automation. First one is automation hierarchy and the second one is basic component of automation system. In lecture 9, ma'am will cover the PLC fundamental, that is the introduction of PLC with PLC origin and evolution, and we will see the internal structure of PLC that contained input module, digital or analog type, output module, digital or analog type, power supply unit and the CPU. So we can say that in the week 3 we moved on to the core of the industrial automation. This week we focused on importance and structure of automation in industry. It covers the hierarchy of automation system and the basic of programmable logic controller, that is PLC, which are the heart of the industrial automation. Understanding this fundamental helps in grasping how automation improves efficiency, safety and reliability in industrial process. In the week 4 is based on PLC programming basics. In this week also we have 3 lectures. Lecture number 11 is based on PLC programming part 1, lecture number 12 is PLC programming part 2 and lecture number 13 is PLC programming part 3. All the 3 lectures in this week are taken by Mrs. Swati Verma ma'am. In this week she will cover the PLC software, memory organization in PLC and PLC programming, addressing modes and the binary concepts and the PLC programming rules and the PLC programming for the basic logic gates. And also she will cover the PLC programming for the universal gates and the special logic gates, Boolean algebra, ladder logic programming, and also cover the interlocking and the latching operation, and also she will cover the basic start stop concepts in the ladder logic programming. So we can say that by the week 4 we were ready to get our hands trained with PLC programming. Across 3 sessions we learned how to write simple programs and gradually increased in complexities. PLCs are at the heart of automation system and mastering their programming is significant step towards become a skilled automation engineer. This session introduced the essential of PLC programming, which is crucial for controlling machinery and processes in industrial settings. The step-by-step progression through programming basic equips learner with the skill to develop simple control programs, laying the foundation for more complex applications. In the week 5 is based on advanced PLC programming with timers. In this week also we have 3 lectures. Lecture number 14 is based on PLC timer programming part 1. Lecture number 15 is also based on timer programming part 2, and similarly lecture number 16 is also based on PLC timer programming part 3. All the 3 lectures are taken by me. In these lectures we covered the mechanical timing relays, PLC timer instructions, T-on timers, T-off timers and their behaviors and examples related to all the timers. And in the last lecture, in the 16th lecture, we cover the retentive on delay timers and their behaviors and their related examples. So we can say that in week 5 we tracked PLC timer programming. So we can say that in week 5 we tackled PLC timer programming. Timer are essential for any process that requires the time-based control. You learned about different types of timers and how to use them effectively. Remember those examples we worked through. From basic delay function to more complex schedule event, mastering timers is a must-have skill. This week you have learned the T-on and T-off timer programming, which is crucial for developing more sophisticated control strategies in automated system. In the week 6 is based on advanced PLC programming based on counters. In this week also we have 3 lectures. Lecture number 17 is PLC counter programming part 1. Lecture number 18 is PLC counter programming part 2. Lecture number 19 is PLC counter programming part 3. All the 3 lectures is taken by me. In these lectures we covered the types of PLC counters, counter instructions and up counter operations. In lecture number 18 we cover one-shot instruction in PLC, ONS instruction, OSR instructions and OSF instructions, and similarly in this lecture we cover the compare instructions and their examples. In lecture 19 we covered the down counters and the compare instructions and their examples. So we can say that similar in this week, similar to timers, counters are fundamental in many industrial applications for counting events or items. Counters are everywhere in industrial automation, from tracking production counts to managing sequential operations. Week 6 was all about the PLC counters. We explored how to implement counter in our PLC programs and how they can help manage process more efficiently. These lectures covered different counters types and their application, enhancing our ability to implement counting function in PLC programs, skills that are vital for effective process control and monitoring. In week 7 is based on application based PLC programming. In this week also we have 3 lectures. Lecture number 20 is related to the star delta PLC program. Lecture number 21 is based on mathematical instruction based PLC program. Lecture number 22 is based on application based on PLC programming, traffic light control and tank level controls. In lecture 20 we covered the star delta starters, why these starters are important and their PLC programmings. In lecture number 21 we covered the mathematical instructions which cover the AND operation, subtract operations, multiply operations, and in lecture number 22 we covered the industrial process programming based on the level sensor based or traffic light based program, and also we will see we saw the car parking programming. So we can say that in week 7 we shift our focus to practical real world application of PLC programming. This week was all about taking the theoretical knowledge we have built up and applying it to the actual industrial scenario. We explored the specific use cases like motor control using star delta starters, where we learned how to design PLC program to manage the starting and stopping sequence of motor efficiently. We also dove into mathematical operation with control logic, which are crucial for tasks that requires precise calculation and adjustment based on real-time data. Additionally, we tackled automation tasks such as traffic light controls, where PLC ensure smooth traffic flow, and tank level management, which involves maintaining and controlling fluid level in industrial tanks. These hands-on exercises were not just about the writing codes, they were about understanding the underlying processes and learning how to use PLC to make these processes more efficient and reliable. By working through these real world examples, you gained invaluable insights into how PLCs are used in various industries to solve complex automation problems, bridging the gap between theory and practical applications. This approach helps you see how each programming techniques fit into larger automation goals, preparing you to tackle similar challenges in your career. In week 8, based on electrical machines fundamentals, in this week we have total 5 lectures. Lecture number 23 is based on principle of electrical machine. Lecture number 24 is based on basic fundamental of AC machine part 1. Lecture number 25 is basic fundamental of AC machine part 2. Lecture number 26 is basic fundamental of DC machine part 1, and lecture number 27 is based on basic fundamental of DC machine part 2. In this week, all the lectures are taken by Dr. Simpi Ralhan ma'am, and ma'am will cover the basics of electrical machine and also the constructions and operations and applications of AC machines as well as DC machines. So we can say that in week 8 was deep dive into the principle of electrical machine. We covered both AC and DC machines, learning about their operations, application and maintenance. Understanding the principle of operation of electrical machine is crucial for anyone working with motor driven systems. These lectures provide foundational knowledge on AC and DC machines, which are integral to numerous industrial applications. Learner gain insights into machine design, operation and maintenance, essential for effective control and troubleshooting. In week 9 is based on fundamental of electric drives. In this week we have total 3 lectures. Lecture number 28 is based on fundamental of electrical drives. Lecture number 29 is based on electric drives, their types and functions, and lecture number 30 is based on 4 quadrant operations. All the lectures in this week are taken by Dr. Simpi Ralhan ma'am. In this week, in week 9, we explore the electric drives. These are essential for controlling motor speed and torque in automation systems. We discussed different types of drives and the concept of 4 quadrant operations, which is important for applications requiring precise speed and direction control, providing a solid foundation for more advanced motor control techniques. Now come to the week 10. Week 10 is based on control of AC and DC drives. In this week we have total 4 lectures. Lecture number 31 is based on AC drive control part 1. Lecture number 32 is AC drive control part 2. Lecture number 33 is DC drive control part 1, and last lecture number 34 is DC drive control part 2. In lecture number 31, in this week all the 4 lectures are taken by Mr. B.C. Rao. Lecture number 31, sir will cover the AC drives and the various methods of speed control of induction motor by adjusting the stator voltage by variable frequency controls and voltage source inverters drive, and also cover the current source inverter drives and cycloconverters. In this week we took it a step further with AC and DC drive controls. This was where we got into the principle of managing motor performance, ensuring you have the skill needed to control speed and torque precisely in various industrial applications. Focusing on the control strategies for AC and DC drives, this session provides a deep dive into the methodologies for managing motor performance in various industrial settings. Mastery of drive control techniques is essential for achieving desired speed, torque, and efficiency in motor-driven applications. Now let's talk about the week 11. Week 11 is based on Introduction to SCADA systems. In this week, we have total 2 lectures. Lecture number 35 is based on Introduction to SCADA architecture and block diagram, and lecture number 36 is based on interfacing of a SCADA system with PLC. In this week, all the lectures are taken by Mrs. Swati Verma ma'am. In lecture number 35, we learned how a SCADA system works with PLC, also the benefits and challenges of implementing SCADA and PLC integrations, and step establishing the communication process between InTouch SCADA and Allen Bradley PLC, right? And so we can say that in week 11 we introduce SCADA systems, an essential tool for monitoring and controlling industrial processes on a large scale, and SCADA, that is supervisory control and data acquisition systems, are crucial for large scale monitoring and control of industrial processes. These lecture introduce SCADA architecture and its integration with PLC, providing insights into a development of comprehensive automation system that enhance control and the data acquisition capabilities across industrial environment. And the last week, means week 12, is based on SCADA programming. In this week, we have total 4 lectures. Lecture number 37 is based on SCADA programming part 1. Lecture number 38 is based on SCADA programming part 2, and lecture number 39 is SCADA programming part 3. And last lecture, that is 40th lecture, is the review of the course material. In this week, 3 lectures, means lecture number 37, 38 and 39 are taken by Mrs. Swati Verma ma'am, and last lecture, lecture number 40, is running, which is taken by me. In lecture number 37, ma'am will cover the basic SCADA programming for switch and lamp, and the same time she will cover the SCADA programming for logic gates and also the properties of vertical and horizontal movement programs. In lecture number 38, ma'am will cover the visibility properties and the touch push button properties, and lastly ma'am will cover the object size properties in lecture number 38. In lecture number 39 is the most important lecture. In this lecture, madam will cover the SCADA scripts, and she will explain how we write the SCADA scripts and which is different to the SCADA programming and which is most important part in the automation system. So we can say that in the week 12 we wrapped up with the SCADA programming. We learned how to design, configure and implement SCADA system to manage complex industrial processes. This knowledge is vital for anyone looking to oversee large scale automation projects, as SCADA systems are central to effective process control and data management. This advanced training is critical for those looking to design and manage complex automation system, ensuring efficient and the safe operation of industrial processes. So we can say that in week 12 we concluded our course with an in-depth exploration of SCADA programming. This final segment of our course was dedicated to understanding the intricacies of designing, configuring and implementing SCADA systems are essential skill set for managing sophisticated industrial operation. Designing SCADA system, we started with the process of designing a SCADA system, which involves creating a blueprint for how the system will function within an industrial environment. This includes selecting appropriate hardware and software components, defining system architecture and establishing communication protocols. The goal is to ensure the SCADA system is capable of integrating seamlessly with existing processes and equipment, providing a robust foundation for effective monitoring and control. Configuring SCADA system. Once the design is in the place, the next step is configurations. This involves setting up the SCADA software to interact with various field devices such as sensors and controllers. Configuration task includes defining data points, setting up graphical user interface and configuring alarm thresholds. Proper configuration is crucial for ensuring accurate data collection and reliable system performance. Implementing SCADA system. The implementation phase focus on developing the SCADA system in real world industrial setting. This includes installing and calibrating hardware, integrating with existing system and performing through testing to verify that everything operates as intended. Implementation is where theoretical knowledge is put into practice and any issue identified during testing are addressed to optimize system functionality. Importance of industrial automation. Mastering of SCADA programming is most important for professionals involved in overseeing the large scale automation projects. SCADA systems are at the heart of process control, enabling real time monitoring and management of complex industrial processes. They provide operator with critical data, facilitate automated responses to system condition and ensure that processes are running efficiently and safely. In summary, we can say that in week 12 provides a comprehensive and practical understanding of SCADA programming, reinforcing the critical role that this system plays in industrial automation. This knowledge is essential for anyone aiming to excel in the field of process control and automation management. So there you have it. Through this course, we have journeyed through a world of industrial automation and drives, from covering essential topics from the basic electrical principle to advanced control system like PLC and SCADA. This series of lecture provides a balanced mixture of theoretical knowledge and practical application, making it an excellent resource for both beginner and experienced professionals looking to a deeper their understanding of automation technologies in industrial sector. I hope this course has give you the tool and confidence to take a new challenges in your career. Thank you for joining us on this journey and we wish you all the best in your future. Keep in touch if you have any question. Until next time, keep innovating. Thank you.